Jupiter, the king of our solar system, reigns supreme with its enormous size and powerful presence. This gas giant, with its swirling clouds and iconic Great Red Spot, has fascinated astronomers and stargazers for centuries. Its sheer size is enough to contain over 1,300 Earths, making it a true behemoth among planets. But Jupiter's grandeur extends beyond its own massive form. It is also the center of a bustling family of moons. These moons, numbering over 79, range from tiny, irregularly shaped rocks to large, planet-like bodies. Each one contributes to the complex and dynamic system that orbits this giant planet. Like planets orbiting a star, these moons dance around Jupiter, each with its own story to tell. Some of these stories are filled with volcanic activity, icy surfaces, and potential subsurface oceans. The diversity among Jupiter's moons is a testament to the varied processes that have shaped our solar system. Some are large and bright, easily visible from Earth with even a small telescope. The four largest, known as the Galilean moons, Io, Europa, Ganymede, and Callisto, were first observed by Galileo Galilei in 1610. These moons are not just large, they are fascinating worlds in their own right, each with unique characteristics. Others are tiny, faint points of light, only recently discovered by powerful telescopes and dedicated astronomers. These smaller moons often have irregular shapes and eccentric orbits, hinting at a tumultuous past that may include capture events and collisions. Among these celestial companions, we find Autonoe, a small and mysterious moon discovered in the early 21st century. Autonoe is part of a group of moons known as the Pasiphae group, which are thought to be remnants of a larger body that broke apart. Its story, like those of many of Jupiter's outer moons, is one of distance, darkness, and the echoes of ancient myths. Named after figures from Greek mythology, these moons remind us of the rich tapestry of stories that humanity has woven around the night sky. As we continue to explore and learn more about these distant worlds, we uncover not just the secrets of our solar system, but also the enduring legacy of our quest for knowledge. In the vastness of space, new discoveries are constantly being made. The universe is a treasure trove of celestial wonders, waiting to be uncovered by those who dare to look beyond the familiar. Each new discovery adds a piece to the grand puzzle of our cosmos, revealing the intricate dance of celestial bodies and the forces that govern them. In 2001, a team of astronomers led by Scott S. Sheppard was using a powerful telescope to peer into the depths of our solar system. These astronomers, driven by curiosity and a passion for exploration, spent countless nights observing the skies, meticulously analyzing data, and searching for new celestial objects that could expand our understanding of the universe. They were searching for faint objects orbiting Jupiter, hoping to add to the planet's already impressive family of moons. Jupiter, the largest planet in our solar system, is a gas giant with a complex system of moons, each with its own unique characteristics and history. The discovery of new moons around Jupiter not only adds to the planet's moon count, but also provides valuable insights into the formation and evolution of our solar system. Their efforts were rewarded when they spotted a tiny point of light moving against the backdrop of distant stars. This faint object, barely distinguishable from the surrounding stars, caught their attention due to its unique motion. The astronomers carefully tracked its movement, confirming that it was indeed a new celestial body. This tiny point of light, barely visible even with their powerful telescope, turned out to be a previously unknown moon of Jupiter. The discovery of such a small and distant object is a testament to the precision and dedication of the astronomers involved. They named this new moon Autonoe, adding another member to Jupiter's extensive family of moons. This new moon was named Autonoe. The name Autonoe is derived from Greek mythology, where Autonoe was one of the many daughters of the river god Asopus. Naming celestial bodies after mythological figures is a tradition that connects our modern scientific discoveries with the rich tapestry of human culture and history. Autonoe belongs to a group of moons known as the Pasiphae group. This group consists of irregular moons that share similar orbital characteristics, suggesting a common origin. The study of these moon groups helps astronomers understand the processes that shaped the early solar system and the events that led to the formation of these celestial bodies. These moons are all small and have unusual, highly inclined orbits around Jupiter. Their orbits are tilted relative to Jupiter's equatorial plane, indicating that they were likely captured by Jupiter's gravity rather than forming in place. This capture process is a fascinating aspect of planetary science, shedding light on the dynamic interactions between celestial bodies. Their orbits are also retrograde, meaning they orbit in the opposite direction to Jupiter's rotation. Retrograde orbits are relatively rare and provide important clues about the history and evolution of the solar system. The study of these moons and their orbits helps scientists piece together the complex history of our cosmic neighborhood, revealing the forces and events that have shaped it over billions of years. Autonoe is a distant moon, located far from Jupiter's familiar inner moons like Europa and Ganymede. While these inner moons are well known and often studied, Autonoe remains a more mysterious and less explored member of Jupiter's extensive moon family. It orbits Jupiter at an average distance of about 24 million kilometers. This vast distance places Autonoe in a region of space where the gravitational pull from Jupiter is weaker, allowing it to have a more elongated and less stable orbit compared to the inner moons. To put that in perspective, that's over 60 times the distance between the Earth and our own moon. Imagine the vastness of space that Autonoe traverses in its journey around Jupiter, a journey that takes it through regions of space that are far less influenced by the giant planet's gravity. At this distance, Autonoe takes about 760 Earth days to complete one orbit around Jupiter. This extended period means that changes in its position relative to Jupiter and the Sun happen very slowly, giving it a unique and prolonged year. That means a year on Autonoe is twice as long as a year on Earth. This extended year affects everything from the moon's exposure to sunlight to the gravitational interactions it experiences with other moons and Jupiter itself. Autonoe's orbit isn't perfectly circular either. Instead, it follows an elliptical path, which means that its distance from Jupiter varies as it moves along its orbit. It's slightly elliptical, meaning its distance from Jupiter changes slightly as it orbits. This variation in distance can lead to changes in the gravitational forces acting on Autonoe, influencing its orbital dynamics and potentially its geological activity. It's also tilted at an angle compared to the plane of Jupiter's equator. This tilt, or inclination, adds another layer of complexity to Autonoe's orbit, making it more inclined than many of Jupiter's other moons. This tilt, known as inclination, is quite significant for Autonoe, making its orbit even more unusual. The combination of its distant, elliptical and inclined orbit makes Autonoe a fascinating subject for astronomers studying the dynamics of Jupiter's many moons. Autonoe is a very small moon, only about 4 kilometers in diameter. That's about the size of a small town. Being so small and far away, Autonoe appears very faint from Earth, even with large telescopes. Astronomers believe that Autonoe is likely irregularly shaped like a potato rather than spherical like our own moon. Its surface is thought to be very dark, reflecting very little sunlight. This makes it even harder to observe and study. Section 5. The Pasiphae group, a family of rebellious moons. As mentioned earlier, Autonoe is a member of the Pasiphae group, a family of moons that share similar orbital characteristics. These moons are all thought to be captured asteroids, meaning they weren't originally formed around Jupiter, but were captured by its gravity at some point in the distant past. The Pasiphae group moons are known for their retrograde orbits, meaning they orbit Jupiter in the opposite direction to its rotation. This, along with their highly inclined and eccentric orbits, suggests they had a turbulent and chaotic past, perhaps involving collisions and gravitational interactions with Jupiter and other objects in the early solar system. Autonoe, a name from Greek mythology. Like many celestial objects, Autonoe's name comes from Greek mythology. Autonoe was a daughter of Cadmus, the founder of the city of Thebes, and Harmonia, the goddess of harmony. She was also the mother of Actaeon, a hunter who was transformed into a stag by the goddess Artemis. The choice of name is fitting, given the moon's distant and somewhat mysterious nature. Just as the mythological Autonoe is a figure shrouded in ancient tales, the moon Autonoe remains a largely unknown world, its secrets still waiting to be revealed. The Mysteries of Autonoe. Despite its discovery in 2001, Autonoe remains a largely unexplored and mysterious object. Its small size, faintness, and extreme distance from Earth make it a challenging target for observation and study. We still don't know much about its composition, surface features, or whether it has any internal activity. Does it have a rocky, icy, or mixed composition? Are there impact craters, mountains, or other geological features on its surface? These are just some of the questions that remain unanswered. Future exploration unlocking Autonoe's secrets. While Autonoe presents significant challenges for observation and study, future missions and telescopes may be able to shed more light on this distant world. Larger, more powerful telescopes, both on Earth and in space, could provide more detailed observations of Autonoe, potentially revealing clues about its surface composition and geology. Future missions to the outer solar system could also be equipped with instruments capable of studying small, distant objects like Autonoe in more detail. Conclusion: a universe of wonders awaits. The discovery of Autonoe serves as a reminder of the vastness of our solar system and the countless celestial wonders that await our exploration. This tiny distant moon, with its unusual orbit and mythological name, holds clues to the early solar system and the complex processes that shaped the Jovian system. As we continue to explore the cosmos, we can expect to uncover many more such objects, each with its own unique story to tell, further enriching our understanding of the universe we inhabit.